What's up guys, today we will do the integral of 1 over x to the power of 6 plus 1. This integral we will use a method blackpenredpen did it, where he did it too in the 1 over x to the power of 4 plus 1, and we did it already in a video of this series. What we will begin with is writing this integral as the integral of 1 over x to the power of 3, not 3, to the power of 2, all of multiply over 3, okay, plus 1 dx, because 2 multiplied by 3 is 6, okay. And we know that a cube plus b cube equals a plus b multiplied by a squared minus ab plus b squared. So we can use this fact to factor this denominator, so we get I equals the integral of here dx 1 over x squared plus 1 multiplied by a is x squared, so x squared which is to the power of 4 minus a multiplied by b, so 1 multiplied by x squared is just x squared plus b squared which is 1 squared which is just 1. By the way, plus, sorry for that. Would it be nice to have an x squared like that? So let's do it. Add x squared and subtract x squared, so get this one, so that you have x squared plus 1. If we split the fractions, same here, x squared plus 1, here x to the power of 4 minus x squared plus 1 plus the integral of, here I will do minus x squared because we have the minus x squared, and the same over the same denominator, which is this. Don't forget the dx. Alright, in this place we can, in this part we can cancel out the x squared plus 1, so we get dx over x to the power of 4 minus x squared plus 1, like that, minus the integral of this part, which is same as x squared over this multiplied by that, which is can go back to the original form, which is x to the power of 6 plus 1, which is the same as x to the power of 3 multiplied by 2 to the power of 2 plus 1. And you see here a nice substitution we can make, because we have the x squared. Alright, well, we have to add a 3 here. This is the derivative of this, so we can do as a usub. For this part, we can use the technique we did with 1 over x to the power of 4 plus 1. So we can write it like that. Here, first we can x to the power of 4 minus x squared plus 1, and we get the x squared plus 1 to help us out. But if we add an x squared here, we have to minus it, so it's minus the integral of x squared over x to the power of 4 minus x squared plus 1. Wait here without, like that. But if you do that, we need a plus or minus 1 here. So let's do a plus 1. Alright, this equals 0. so it doesn't work. So we have to minus 1. So let's check. This x squared minus x squared is 0. 1 minus minus 1 is 2. So we have to divide by 2 to preserve the value of this part. Then minus, here we need the derivative of this thing. So let's do it. Can divide over 3 and multiply by 3. So we get 3x squared over x to the power of 2 squared plus 1 dx. The second step for this part is to divide everybody by x squared. So you get I equals 1/2 of the integral. Actually we have two integrals because we can divide the integral. We have can divide everybody by x squared, so we get 1 plus 1 over x squared, and this part will be x squared minus 1 plus 1 over x squared, like that. By the way, here dx, just forget to write it down. Write it nicely. Dx minus, yeah, alright. So here we have the dx minus the integral of, can also write yeah, we can use factor this 1/2 because it's without distributing it. So it's the integral of 1 minus 1 over x squared, and here x squared minus 1 plus 1 over x squared dx, like that. Then the bracket, close it. So this is the same as that. We just divided everybody by x squared, okay? Then this part we can do it easily, just easy. We get 1/3 of the inverse tangent of x to the power of 3. Without plus c we didn't finish this. Alright, let's name this as g. Let's name it as g. Here is the g, and do the g here. You have the g equals the integral, this integral. Before writing it down, would like to complete the square for this part. I have to complete the square of the denominator. Alright, so that we get parentheses plus 1 over x, or x minus 1 over x. This will give us, by differentiation, 1 minus 1 over x squared, and here will give us 1 plus 1 over x squared. So we can do a u sub for this two to cancel out the numerator, and we get at the end inverse tangent or inverse hyperbolic tangent. Alright, for this part we need this, so we have to do the minus. So for this part we'll write it down. We need the minus version, and here we need the plus version to do the u sub. Alright, let's do the completing the square. Let's complete the square. We have the I, the g, sorry, the G equals, G is the inside bracket. I will not include the 1. Okay, so it will be the integral of dx, and here dx, plus the integral of, and here dx2. Okay, here 1 plus 1 over x squared, same with this 1 minus 1 over x squared. With this part we need to do the minus version for the completing the square. So we do x squared minus 2 of x multiplied by 1 over x plus 1 over x squared. This is just a minus 2. So we have to add the 2 to preserve the value of this. So add a 2, and don't forget the minus 1. We have plus 2 minus 1 is just plus 1. So here we have plus 1, like that. Same for this part, x squared. Here don't do minus 2, do the plus 2, because we need the plus version. So you get x 1 over x plus 1 over x squared, and here is just plus 2. So we have to minus 2 to preserve the value of the fraction. And don't forget the minus 1. Minus 2 minus 2, 1 is just minus 3. So we get that. So G equals the integral of 1 plus 1 over x squared, and here x minus 1 over x squared plus 1 dx, plus the integral of this part, which is dx 1 minus 1 over x squared, here squared, x, here x plus 1 over x. Here we see that this, the derivative of this is the same as that, and the derivative of this is the same as that. So minus 3, like that. Alright, so G equals the integral of what? Let's use as u sub for this part. Let u equals x minus 1 over x. So that du equals, the derivative of this is just 1 plus 1 over x squared dx, which is the same as that. Same for this part, let's use a z. Z equals x plus 1 over x, so that dz equals 1 minus 1 over x squared dx, which is the same as that. Therefore G equals the integral of what? Here we have u squared plus 1, this whole thing, same for this, it will be a du, okay, du plus the integral of dz over z squared minus 3. And here I would like to flip the order, because we know that x squared minus 1, the integral of this, equals the inverse hyperbolic tangent of x. So we need 1 minus the constant minus x squared. Here we have the x squared minus the constant. So to flip it, we multiply by minus. Okay, so when we multiply by multiplied by minus here, so we get 3 minus z squared, like that. Alright, this part will give us inverse tangent of u. And what is u? U is the same as that, is x minus 1 over x. We will replace it later. And here I would like to write it square root of 3 squared, which is the same as 3. Why? Because we have the rule, which is the integral of dx over x over a squared minus x squared equals 1 over a, then the inverse hyperbolic tangent of x over a. We have this rule, so we need the constant square. So this will be minus 1 over square root of 3, then the inverse hyperbolic tangent. You may write the n right, yeah, like that, of z over square root of 3. Alright, let's replace the u and z because we need the x. This will be the inverse tangent of x minus 1 over x here, minus, this can be written as square root of 3 over 3, just better looking. Then the inverse hyperbolic tangent of what? Of z over square root of 3, which is same as, this will be x over square root of 3 plus 1 over square root of 3x, like that. Alright, we have also a rule, which is the inverse hyperbolic tangent of x equals 1/2 of ln x plus 1 over x minus 1. So we can use this fact for writing the inverse hyperbolic tangent in terms of logarithm, natural logarithm. So we have the g equals, equals the inverse tangent. Can unifying the denominator, we get here x squared minus 1, like that, minus square root of 3 over 3 multiplied by 1/2 of ln what? This plus 1, so it's x over square root of 3 plus 1 over square root of 3x plus 1. Same for this part, x over x square root of 3 plus 1 over square root of 3x, here x in the denominator, minus 1, so it's plus 1 minus 1. Can multiply the numerator and denominator, can do parentheses, multiply here by square root of 3x, and here square root of 3x. To simplify things a bit, so we get g equals the inverse tangent of x squared minus 1 over x minus square root of 3 over 3. Here it will be just over 6, because 3 multiplied by 2 is just. Then we have the ln of what? X over x square root of 3 multiplied by this, it will give us x squared. Same for this part, it will be plus 1, and plus 1 multiplied by that is just plus square root of 3x. Same with this, x squared, here plus 1, but this time we have a minus 1 multiplied by that, so it's minus square root of 3x, like that. We can do one thing more, which is g equals the inverse tangent of x squared minus 1 over x minus square root of 3 over 6. Here we can use the plus, the minus, to flip the logarithm or the fraction order. So we have the x squared minus square root of 3x plus 1, like that. And here x squared plus square root of 3x plus 1. Alright, now we can write the I as a whole expression. It will be, the I will be this multiplied by 1/2, so it's 1/2 of the inverse tangent of x squared minus 1 over x plus square root of 3 over 6 over 2, which is 12. Then we have the ln, logarithm, which will be x squared minus square root of 3x plus 1 over x squared plus square root of 3x plus 1. Then we do a minus for this, so it's minus 1 over 3 inverse tangent of x cubed plus 6. This is the full answer. However, I want to discuss one thing more. This result we got is not defined on 0. Why? Because we divided by x squared, so it's not defined for 0. If you do for GeoGebra site, you will get its graph. It will be like that, then directly jump to here. How to fix this? We can actually look the limit from the negative side. Let's write it down. We have the limit of x approaches 0 plus of I equals inverse tangent of x of 0 is 0, so this part is excluded. Same for this, 0 minus 0 plus 1, just plus 1, 0 plus 0 plus 1 is just 1, so 1 over 1 is just 1, ln 1 is 0. then this part, let me write it like that, 0 squared minus 1 over 0 plus. This part will give us just 1 minus 1 over 0 plus, it will give us minus infinity. Inverse tangent of minus infinity is minus pi over 2. And minus pi over 2 is minus pi over 4. So if we look at the graph again, you see that it begins from this. This in fact is minus pi over 4. Same for that. Here in this place is pi over 4. So we can do a continuous extension for this function I. So we can let the f x equals 1 over x to the power of 6 plus 1, and f, big F, for x equals an extension, which is this extension. Let me write it lower. So we have three expressions here. First one, it will begin from minus infinity to 0. It will be the same thing, which is I, but minus pi over 4. When you do a minus pi over 4, you will get this graph. You will get something like that. Say for this, to make it up, you have to add pi over 4. So it will begin from this side. And in 0, you write 0, just 0. Because they end up in 0, okay? The limit from this part, and this end, it will be just a 0, okay? And this is plus c, so you can get the graph doing like that, it's okay, it's normal. But to have a jump, it's better to give an extension and continuous extension for it to get the continuity. So here we have if x is between minus infinity and 0. 0 is not included. Same for this, x is between 0 and plus infinity, and 0 is not included. And here you can write if x equals 0. Alright, that's it. So this is this integration we can work for 0, it's okay. Alright, anyway, that's the answer. So I hope you like the video. If you have any ideas, leave them in comments below. Alright, see you next time. Goodbye. Sorry for this mistake. I forgot to write the minus here. So this is minus from this. So this will become minus. And here, when you flip it, it becomes plus. So it's always plus, 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 plus. And here, you don't need to flip it. So it will remain the same. So you get here plus over minus. Okay, sorry for this mistake, it's really stupid. Anyways, that's it, that's the correct answer.